Inside the $25 billion artificial sun project, humanity has finally crossed the boundary between science fiction and reality. Deep inside a colossal underground facility, the world's most powerful fusion reactor continues to burn, not with fire, but with controlled stars. After years of preparation, the system now operates in a stable state, producing continuous clean energy through artificial solar fusion. Gigantic superconducting magnets hold the plasma core in perfect suspension, shaping a miniature sun inside a man-made shell. Every second, sensors across the structure monitor temperature, pressure, and magnetic stability, adjusting in real time through advanced AI control systems. Energy no longer remains trapped in theory. It flows through massive conversion chambers, transforming raw fusion output into usable electrical power. Across holographic global maps, cities begin to light up as simulated grids confirm successful energy distribution. Engineers watch silently as equations turn into reality, powering entire regions without a single drop of fossil fuel. Heat management systems activate in perfect synchronization, releasing controlled energy bursts through vertical cooling towers that stretch deep into the Earth's infrastructure. For the scientists inside the observation deck, this is more than a breakthrough. It is a turning point in human civilization. The artificial sun glows steadily behind reinforced containment fields, a perfect sphere of controlled plasma suspended in magnetic harmony. There is no chaos anymore, only precision, balance, and unimaginable scale. What once seemed impossible is now contained, stabilized, and operational. As the facility enters full steady-state production, the world outside remains unaware of the silent revolution happening beneath its surface. But inside, everyone understands one truth: humanity has not just built a reactor. It has built a star. When the reactor reaches ignition level, everything changes in an instant. Inside the tokamak, hydrogen gas has already been transformed into plasma. The magnetic field tightens. Energy levels rise. Every system begins to push closer to the edge of control. Then it happens. A sudden fluctuation appears inside the electromagnetic ring. At first, it is small, almost unnoticeable. But within milliseconds, the instability grows. The plasma begins to shake inside the magnetic cage. Energy distribution becomes uneven. One section of the massive electromagnetic ring starts to fail slightly. And that small failure changes everything. Energy leakage appears as faint sparks along the containment field. Plasma arcs violently across invisible boundaries, trying to escape the magnetic grip. The reactor begins to lose perfect symmetry. In the control room, alarms trigger instantly. Engineers rush across the background. Screens flash with rapidly changing data. Red warnings spread across holographic interfaces. The artificial sun is no longer stable. Inside the chamber, the plasma reacts violently. Temperature spikes. Magnetic pressure fluctuates. The entire system enters a dangerous state where failure could mean total reactor shutdown, or worse, structural damage to the facility itself. But the system is not human. It is designed to respond. Automated emergency protocols activate immediately. Magnetic coils increase power output. Backup systems engage within fractions of a second. The containment field strengthens, trying to pull the plasma back into alignment. The chaos inside the chamber reaches its peak. For a moment, it feels like the artificial sun might break free. And then something unexpected happens. The system begins to adapt. Not manually, but automatically. A hidden layer of intelligence inside the reactor starts recalculating every magnetic variable in real time. Adjustments begin faster than any human reaction could ever match. And the unstable star inside the CHA. To attempt something as extreme as creating a star on Earth, scientists built machines that look like they belong in the future, giant circular reactors known as tokamaks. At first glance, it looks like a massive metal ring. But inside this structure lies one of the most complex systems ever engineered by humanity. The goal is simple in theory, but almost impossible in reality. To recreate the power of the sun, scientists must force atoms to collide at unimaginable speeds. But before that can happen, matter must be transformed into something completely different, a state called plasma. Plasma is not solid, liquid, or gas. It is a superheated state where atoms are stripped apart into charged particles. It only exists at temperatures reaching over 100 million degrees Celsius. That is hotter than the core of the sun itself. So, how do you hold something that hot without letting it destroy everything it touches? The answer is invisible force. Instead of physical containers, tokamaks use powerful electromagnetic fields. These magnetic fields act like invisible walls, suspending plasma in midair so it never touches the reactor surface. Floating, burning, rotating, controlled. Inside this magnetic cage, hydrogen atoms are injected and accelerated. They begin to collide at extreme speeds. When the conditions are perfect, something incredible happens: the atoms fuse together. And when they fuse, they release energy. Not small energy, but massive bursts of power at the atomic level. This is nuclear fusion. But even with this design, controlling the reaction is extremely difficult. The plasma is unstable. It moves unpredictably. It resists containment. One tiny imbalance in the magnetic field can cause the entire reaction to collapse instantly. That is why every experiment requires years of preparation and only milliseconds of success. And yet, inside these machines, humanity is trying again and again to capture the energy of a star. But the real challenge is not just Crete. Deep beneath the surface of our modern world, something extraordinary is being built. Not a weapon, not a machine of destruction, but a system so powerful that it could change the future of human civilization forever. This is the story of the $25 billion Artificial Sun Project, a scientific experiment so advanced that it attempts to recreate the very source of life on Earth, the sun. But why would humanity try to build a star on Earth? The answer begins with a crisis we are all facing: an energy crisis. For decades, the world has depended on fossil fuels like oil, coal, and gas. They power our cities, our industries, and our technology. But they also pollute the atmosphere, damage the planet, and are slowly running out. Even renewable energy sources like wind and solar, while powerful, are still not enough to fully meet global demand. So scientists began searching for something different, something limitless, something clean, something that could power the world without destroying it. And they found it inside the same process that powers the universe itself: nuclear fusion. The same reaction that makes stars burn in the sky. The same force that has kept the sun shining for over 4.5 billion years. But here's the impossible part: the sun works because of its gravity. It naturally crushes atoms together under extreme pressure and heat. On Earth, we don't have that luxury. So to recreate a star here, scientists must build something even more extreme than nature itself: a machine capable of controlling fire hotter than the sun. A machine that does not just generate energy, but contains a star inside a chamber. And this is where the most expensive scientific experiment in human history begins: